Assalamualaikum. So today I'm going to explain on the slope stability analysis part B. So we're already in week 10, and here the learning outcomes. As you can see here, at the end of this week 10, so students should be able to analyze stability problems for total stress analysis. Total stress analysis means that undrained, and effective stress analysis for drained conditions. So both we are using a method of slices. Okay. So as you can see here, first we look at the total stress analysis. Right. Okay, we put aside first. Okay, we look at the total stress analysis for means that CU and phi U. So phi U is equal to 0. So for this case, phi U is equal to 0. Okay, so the difference between this method with mass procedure method is that for mass procedure method, so this is still remember, so this is the outline. Okay, this is the outline where the slip failure plane occur. Okay, and let's say this is A and this is B. So this is a sector of AOB. Okay, AOB sector. Okay, so if the one that I explained last week, the mass procedure, so you have to determine all the mass, okay, mass for this section without make it into a few slices. Okay, but for this week, when we use method of slices, okay, what you have to do is you have to draw this figure. You have to draw this slope section. You have to draw on the graph paper with a scale. Okay, so when you draw this slope on the graph paper with a scale, a correct scale and dimension given, so you can divide this section. Okay, this section you can divide it into a few slices. Okay, normally the slices we divide to the same B. Okay, if each slice have a same B. Okay, same B. So meaning that each slice will have W. Okay, let's say this is slice 1, slice 2, slice 3, slice 4, slice 5, and slice 6. Okay, so each slice will have a W. W is due to the gravity force. So W is a disturbing force. So each center of the slice, you will have W1 for slice 1, center slice 2, so W2 for slice 2, center of slice 3, so this is W3 for slice 3. So this would be W4 for slice 4, W5 for slice 5, and W6 for slice number 6. Okay, for slice 1 and slice 6, because of it looks like a triangle, so the best is you take W at the center of the triangular. Okay, at the center of the triangular. But you still can take it at the middle. Okay, because this is B. If this is B, so at the middle, this is B, so at the middle, or 2/3 or 1/3. Okay, then what you should do next, okay, each slice will have D is a distance from point O, this point O, centroid of the sector, to the W. Okay, so we have W1, W2, W3, W4, W5, and W6. Okay, and then D must be measured from O. Okay, so we're going to have D1, D2, D3, so they will be D4, D5, and finally D6. Okay, then you have to remember a positive and negative sign. Okay, why this side positive, this side? Okay, right hand side is positive, left hand side is negative. Why? Because we are taking moment at O. So right hand side, this W, this force will make a movement clockwise. Okay, so this one, so W3 clockwise, W4 clockwise, W5 clockwise, and W6 also clockwise, except for W1 and W2, because W1 anti-clockwise and W2 also anti-clockwise, so that's why the sign is negative. Okay, so disturbing moment, remember moment, when moment we must have force, which is W, and distance, which is D. Okay, restoring moment. Okay, restoring moment means that as resistance along this outline A, B. Okay, along this outline A, B, there's a shear strength. Okay, along this outline A, B, this is B, so there's a shear strength. So shear strength is equal to Cu, because of phi u is equal to 0. Okay, so restoring moment, okay, is equal to cu r squared theta. Cu r squared theta, because r theta is the outline A B. Okay, this outline AB is equal to r theta. Okay, so you have to times with Cu. Okay, so that is your resistance force. Okay, when Cur theta, that is your resistance force. Okay, the distance is r. Okay, r is the distance from O to the outline AB. So r is the distance force. So that's why, okay, Cu r theta times with r, so you will get Cu r squared theta. Okay, so factor safety is always restoring moment or resistant moment divided by disturbing moment. Okay, disturbing moment. So factor safety equals to Cu r squared theta over Wt. Okay, then we look at how you tabulate from the graph. Okay, from the graph, you can see here from the graph. Okay, so you remember just now we have 6 slices, right? So 6 slices, 1 1 1 2 3 4 5 and 6. Okay, 6 1 2 3 4 5 6. Okay, so you have to tabulate into 1 2 3 4 5 6. Okay, 36. It depends on how many slices that you have. Okay, so column 1, okay, let's assume that this is column 1, is B. What is B? B is the breadth of the slice. So you're going to have B1, B2, B3, B4, B5 and B6. Normally B are equals. We make it easier, so we divide the slice into an equal B. So let's say B is 2 meter, 2 2 2. Okay, and H, what is H? This column number 2. H is the average height at where you assume W occur. So this is W at the center, W at the center. So H, this is H, this is H. So W at the center, so this is H4. Okay, H4, this is H4. Let me, okay, so H, this is H2, H1, H3, H4, H5, H6. Okay, so then area. So area you can simply B times H, so you will get area. So then next is W. So W, as I told you last week, is equal to gamma A. So area, so gamma depends on the type of soil given and the unit weight given. Then D, so D is the distance from O to the W force, okay? And then you can get WT, okay? W times D. Then you total up, so you will get total of WT. So this value will be here, and then you have to calculate CUR squared. Okay, so we look at another way. Okay, another way of method of slices. Still Swedish method. So this, if we look here, we have cos alpha. So cos alpha, sin alpha. Okay, so we'll have phi u equals to 0. Okay, equals to 0. So use this. Okay, T is tangential force. Is this direction, downwards, and is the normal force acting perpendicular to the outline, so perpendicular to T. Okay, then W is the force acting to the gravity. Okay, so you have to use this equation. Okay, the difference between this method with the previous ones, that you have to determine alpha instead of D, right? Because the previous one you use W times D, right? But this time we are not using D, no, but we have to look for alpha. Okay, so still the same, W must be at the center of each slice. So W1, W2, W3, W4, W5, and W6. So how to get alpha? Okay, to get alpha, you have to take here at the cross between W and outline to the position O. Okay, so that would be alpha 5. Same goes to this, will be alpha 6. So this one, so between this is alpha 4. So depends on this one. Okay, so this is alpha 3. This is alpha 2, and this is alpha 1. Okay, so same like previous, whatever on the right, the alpha value will be positive. Whatever on the left side, the alpha value will be negative. So alpha 1, the value is negative because this side. Alpha 2 is also negative. Okay. Positive alpha is for alpha 3, alpha 4, alpha 5, and alpha 6. Okay, remember to get the alpha is from point O to the W. Okay, student always make mistake when they drag a line from O to boundary line. Okay, this is boundary line of the slice. Okay, so student make mistake from O, so here, and then they measure alpha here. Okay, let me show you the difference between. Okay, that's okay. The mistake that student did here, so they measure this. This is wrong. It is not a line taken from O to the boundary line. You're supposed to take a line from O to W. This is W. So the green line is the correct one. This blue line is wrong. Okay, so that's how you get all the parameters. Okay, hope you can understand what I explained here. Okay, so the table so the table would be a little bit different with the previous one. Just different these last 3 columns. Okay, B is still the same. B, the breadth of the slice. So this is the slice. So what is the breadth of the slice? Okay, so normally we ask for to make it into a few slices with a equal breadth. Okay, so you can fill up the table. H is the average height, the average height, where you consider the weight, the W. Okay, and then area is B times H. It's much easier. Or you can you want it more accurate, so you can use trapezium formula for the area. And then W equals to unit weight times area. And then the new one is the alpha. So alpha, if you have 6 slices, so you must have 6 alpha. Okay, and then and the normal force. So the normal force is equal to W cos alpha. So each alpha, so times with this is the W, so this is the alpha value, so this is W, this is column 1, 2, 3, 4, 5. So it means that column 4 times with column 5 cos alpha. Okay, cos alpha. And for T is W sin alpha. Okay, W sin alpha. Then so total up T and total up N. Okay, this is the formula for factor safety. Okay, when phi u is equal to 0, actually this formula is come from the Terzaghi formula. You still remember shear strength theory, which is I use more clear. Okay, so shear strength is equal to C plus normal stress tangent phi. So this is actually this one. Okay, so why there is R here, R squared, and R here? Because R is the distance of the force. Okay, so that's why we times this R. So both sides are here, so R squared. So that's why C R squared theta plus R summation of N tangent phi, but this is equal to 0, and this is a force, so you have to times with the distance R. Okay, so you can simplify by cancel R cancel and cancel R. So finally FOS is equal to CR theta over summation of T. Okay, T is W sine alpha. Okay, next, hopefully you clear on this method. Next one, example of Swedish method of slices. Okay, right, the example, so this is from Smith's Element of Solid Mechanics 9th edition. So Swedish method of slices, so this is the question. Okay, this is the height of the slope, is the radius. Okay, so normally it will tell you what is the slope. Okay, so CU and gamma. Okay, so determine the factor of safety in the short term. So short term means it is undrained condition. Okay, and it is homogeneous. Okay, so divide into few slices. One tip that I want to give you, always if you want to make it slices, this edge, this slope and a horizontal surface, ground surface, and this slope, inclined slope, always take this as a one slice. Okay, this as one slice. Alright, so let's look at the solution. Okay, here is the solution. So we divide into 4 slices. Okay, 1 2 3 4 slices. Okay, with equal B. So means that we have 4W. So W1, W2, W3, and W4. Okay, and then weight. Okay, weight is the gamma. Okay, times with the area. Okay, area. Okay, so we get weight, so W, so we have W1, W2, W3, and W4. Okay, and then normal force. So normal force, what is the formula for normal force? Remember just now? Normal force N is equal to W cos alpha. So T equals to W sine alpha. Right? Okay, so after you get the W1, W2, W3, and W4, so what next? Okay, you have to determine alpha. So this is alpha 4. This will be alpha 3. So to get alpha, so this is alpha 2, and this one, this is alpha 1. Okay, from this one, only alpha 1 on the left side. Remember, left side must be negative, right side must be positive. So alpha 1 is negative, because if okay, so alpha 1 is on the left side, alpha 2, 3, and 4 on the right side. Okay, so as you can see here, why T is equals to negative? Because W sine negative alpha 1. Okay, we have to determine alpha here. Okay, so this book just give a shortcut solution. So you have to find out. Okay, so you have to plot on the graph paper. So try to solve this questions, so the exercise by yourself. So try to get familiarize how to get the alpha. So this will be negative something, so this would be positive, and positive. So cos for this is N is where W cos negative for this one. So slice 1, N1 is equals to W cos negative alpha. Okay, so cos negative alpha is positive. Okay, so that's why you get 71 here. But for W sine negative alpha, so you will get negative. So get N1, N2, N3, N4 and sum. T1, T2, T3, T4 and sum. Okay, so CU FOS is equals to CU R theta over summation of T. Okay, so where is N? Where is N in this formula? Why there is no N? Why? Anybody can answer? Okay, why N is not included in this equation for S? Why? cos phi u equals to 0 and tangent phi equals to 0. Now we look at effective stress. Effective stress, so when effective stress, this is C prime and phi prime. Okay, so actually we have a lot of methods for method slices. We have Frillenius, we have simplified Bishop, we have Morgenstern, and many more. For this CEG561, we only focus on these two. Okay, these two, the Frillenius and simplified Bishop. Because of the simplified Bishop is is a little bit complicated. Okay, so just intro to you, and for your syllabus you have to focus on this Frillenius. Okay, what you can see the difference here, the comparison between Frillenius and simplified Bishop. So we have interslice forces. Interslice forces is can you see E1 and E2, so that is interslice forces. Okay, and you can see the comparison between the Frillenius and simplified Bishop in terms of interslice forces, in terms of resultant interslice forces, right? In terms of resultant forces direction, vertical, horizontal, in terms of consideration of interlaced normal force. Okay, for Bishop it's considered interslice normal force, but for Frillenius there's no interslice normal force. Okay, it's not considered the interslice normal force. Okay, what we have here. Okay, so for effective stress analysis, actually still same with total stress analysis. You make it into a few slices. Okay, and then you will get W for each slice, W at the center of the slice, and then you will know the B, okay, for each slice, B for each slice, B, and then you will know you will get the alpha. Okay, so either you measure from here or here. Okay, still the same. This angle and this angle are the same angle value. Okay, so alpha H, okay, so B alpha H, okay, R, okay, so only that this is the new it's not new, it's the different between total stress and effective stress. Okay, L is actually outline, but for effective stress analysis it's consider the outline as per slice. Okay, so you will get, let's say this is slice 1, slice 2, 3, 4, 5, 6, 7, 8, 9. So you will have slice L1, L2, L3, L4, L5, L6, and so on until L9. Okay, so summation of all L1 until L9 is actually equal to R theta, which is the outline of AB. Okay, but for effective stress analysis, it divided into slices to make it more precise. Okay, so then for effective stress, if there is a water hydrostatic pressure occur, so remember that you have to minus with U. U is always a pore pressure. U is a pore water pressure, so times with L. So you will get N prime. Remember we have N and T. So for effective stress always have prime sign. Okay, effective stress, right? So prime sign, so equals to so shear strength is equal to C prime plus normal stress prime tangent phi prime. Okay, this example I took it from Principles of Geotechnical Engineering, Braja and Das. Right. Okay, so the question asks to use ordinary method of slices. So ordinary method of slices is also Fellinius method, right? So use Fellinius method. So it already show you it divide into seven slices. So the number one is start from here, 1, 2, 3, 4, 5, 6, 7. Okay, and then so W1, W2, W3, W4, W5, W6, and W7. Then determine alpha. So alpha 1 70, then alpha 2 is 54, alpha 3, alpha 4, alpha 5, alpha 6, and alpha 7. Okay, so from this figure you can see how many negative alpha. Okay, so we have alpha 7 is negative. How about alpha 6? Alpha 6 is equal to 0. Why? Because it's immediately under the point O. Alpha 1, 2, 3, 4, and 5 are positive alpha. Okay, now we look at the solution. Okay, so we have 7 slices, 1, 2, 3, 4, 5, 6, 7. Then we have 7W. So W is from gamma A, so that is W. And then alpha, so make sure in degree. So alpha is measured degree. And then sine alpha, so when negative 8 sine alpha, sine negative 8 is negative 0.139, but it is positive for cos. Cos negative 8 is 0.99. Okay, so this book, Braja MDAS, it use delta L. Actually, delta L is equal to L. Okay, so each L1, 2, 3, 4, 5, 6, and 7. So total L. So this total L can be considered as LAB, or R equal to R theta. Okay, so then W sine alpha, then total up, and finally W cos alpha, total up. Do we need to determine N for this case? Because this is T, this is N. Do we need to determine N for this example? Yes. Why? Because phi is not equal to 0. Okay, so we have phi is 20 degree. So we need to determine N. So for this one, C prime LAB plus N prime. So this is actually formula FOS equals to C prime R theta plus N prime tangent phi prime. Okay, divide by T. Okay, so just put all the calculated formula here. So column 7 is T, column 8 is N. Okay, so FOS is 1.55. So that is how you solve this example. If you don't want to use column 6, it's okay. You can use R theta instead of column 6. Summation of L, you can use R theta because we know the R value and the theta value. Okay, so this is an example from Braja MDAS. Next example, I took it from Basic Soil Mechanics. Majority of you have this book from Whitlow. Okay, so work example 9.9. So it asks you to determine factor of safety in terms of effective stress. For the slope in figure, this is the figure. Okay, O is here. So LAB, outline AB. So we have 8 slices. 1, 2, 3, 4, 5, 6, 7, 8. So 1/3 here is a 1/3 because the middle of the this triangle. So the middle, this is middle, W3, W2, is W4, W5, W6, W7, and W8. Okay, and W is equal to gamma HB. Why gamma HB? Because area is equal to BH, HB or BH. So H is the average height of the each slice. B is the breadth of the slice. Okay, so UL, okay, in this equation there's a water table here, ground water table. So in this slope, okay, you have to determine HW and total H. Okay, what is the difference between this H and HW? Okay, H is the total height. Total height. For example, for slide 7, this is H. Okay. Okay, this is H. Okay, but this is where the groundwater level. This is HW. Okay, from the groundwater table to the line AB, that is HW. So HW is 4.1. Okay, but the H is 7.2. Okay, same goes to the rest of the slices. Let's say slice 8. HW is 1.3. This is 1.3. This is HW for slice number 8. And but H is 3.7. H is 3.7. W as usual. Area times unit weight. So HW, L, remember L, what is L? L is B second alpha. Okay, and then we have UL. So what is U? U is gamma water times with HW. That is U. Okay, U equals to gamma water times dengan HW. So that is U. So UL, so gamma water times with HW times with L. So that is UL. Okay, then N is, what is N? N is W cos alpha. And how to get N prime? N minus UL. So this is N prime. So T is W sine alpha. Okay, that is T. So sum for N prime and sum for T. So you will use equation. So this equation. Okay, so this N. So you see here, Whitlow use LAB equals to R theta, but Braja M does use LAB equals to summation of L. Summation of L here. Okay, so it's up to you, but must fix. If you use this, the LAB equals to R theta, so every time you do the exercise, so you just remain the LAB equals to R theta. Okay, so C prime R theta plus summation of N prime. So N prime is N minus UL, so tangent phi prime. So summation of T, where T is equal to W sine alpha. Remember, S is always with T, so S is a sign. Then finally you will get the answer 1.05. Okay, so FOS normally it's less than 3, or maybe just a little bit of 3 point something. When you do exercises, when you get your FOS is equals to 100 or 20, 50, so there must be something wrong with your calculation. And another exercise that I took from Whitlow. So a soil layer slope is not always one layer, so it can be 2 layers. Okay, so look at this example. For layer 1, okay, layer 1, the outline is LFB only. Okay, so layer 1 outline, the strength is only along length FB. Okay, and the theta is FOB. Okay, theta is FOB. And for layer 2, the strength is along length AF, and the theta is AOF. Okay, so meaning that this is sector 1, and this is sector 2 for layer 2, because the shear strength is along line AF only. Okay, so the theta, this is the theta 79.9. So this is theta 2 for layer 2. Okay, so this is theta 1 for layer 1. Okay, this is theta 2 for layer 2. Okay, so to get W, because each slice, okay, it might combine layer 1, W1 and W2 gamma. I mean unit weight 1 and unit weight 2, because normally we have unit weight 1, gamma 1 and gamma 2. So let's say this one, for example, W for slice 8. Okay, W8 is actually combination of gamma 1, H1. So this is H1 because it's in layer 1. Gamma 2, H2. This is H2. Okay, H2. B is the rest. Okay. B is the rest of the slice. Okay. So remember, for effective stress, always use C prime, 5 prime. Okay. Alright. So the solution is still the same. 9 slices, because we have 9 slices. 10 slices. So 10 slices. So we have H1. H1 is the height, average height from layer 1. Okay. ni from layer 1, H2 is from layer 2. Okay, and then W is where you get from gamma 1 H1 plus gamma 2 H2 times B. Okay, X, what is X? X is like D. Okay, in this book, Whitlow, the author used X instead of D. Okay, if you look here, X is the distance from okay, this one. X is the distance from point O to the center of the slice to W. So same concept, everything on the right will be positive, everything on the left will be negative. So same like X. So from here to here is X 6. So here from middle of the slice 5 to here is X 5. Okay, right. So okay. And then alpha as usual. Right, so for this time, instead of use UL, but you use RU second alpha. Get this for each slices, and then you will get N prime, right? N prime, and then you will get T. So negative, the first 3 is negative because you can see 1, 2, 3 is on the left side of the point O. Okay, so finally some T value, right? Then so this is the one that I told you. U is because RU gamma H. Okay, so use this equation, just a little bit different with the previous one. So the first part is still the same. C prime L. L is actually this L is actually L AB. So this equation W sine alpha is still the same T. So tangent phi prime. So the just difference is somewhere here. Instead of W cos alpha minus UL, but you use W cos alpha minus RU second alpha. Okay, and because of this is 2 layers, okay, 2 layers, so the theta is also 2. So that's why we can see this is the first part, this is the second part. Okay, so this is the first layer, second layer. Okay, first layer, FB. Okay, FB is the layer 1. Okay, AF is layer 2. Okay, so 19.3 19.37. This is typo error. Okay, so 19.37 or 19.39, whichever is the correct one. Okay, then 5.75 is the L, so this is C. This is C prime 1, so 7 is C prime 2. Okay, so C prime 1 and C prime 2, right? So tangent y prime for layer 1 is 12, and prime for layer 1 is 0. This is phi 2 is 25 degree, and prime for layer 2 is 1040. So finally the FOS is 1.25. Okay, 613 is last part of this video is about the Bishop's simplified method. If you look here, Bishop's simplified method, even though it's simplified, but it's complicated. As you can see here, okay, there is F. If you can have a look here, F in this formula, F is factor safety. So the factor of safety, okay, actually it's from the same formula with the filling, same formula. This is the strength, shear strength formula. Okay, but due to this force diagram, okay, so Bishop come up with factor of safety with this long equation, and this F is actually factor safety. So meaning that finally, okay, factor safety is equal to 1 over summation of W sine alpha summation of these. So there is a factor of safety. So meaning that you have to do trial and error. Okay, so for the factor safety for the first trial, you have to use M alpha is equal to 1, so F1 is equals to column 10 divided by column 5. Okay, so that will be your F1. Okay, that your F1. After you get your F1, this value from F1 you have to put it here, and then that will be the second trial. Okay, the second trial, you have to calculate until you get F2, and then that F2, okay, that will be another trial, third trial. Okay, so finally you calculate. If you manage to get the factor safety, which is equal to the factor safety, same with the previous one, so you can stop. If not, you have to continue with another trial. It can be until 8 trial. Okay, so that's all. Okay, I think that's all for week 10. Try to solve final exam question December 2019, question 3B. So this is example of math procedure question of slope. And then June 2019, question 3B, that is example of method of slices. Okay, for this week week 9 and week 10, actually you have to draw your slope on the graph paper, okay, with a proper scale, so then you will get the theta. Okay, hopefully you try to get the graph paper, the protector, okay, if possible. If not, you just stay at home, stay safe, and good luck for your ODL. Thank you and selamat hari raya.